Since the dawn of humanity, we have looked up at the night sky and wondered about our place in the cosmos. The universe is a vast and mysterious place, full of wonders that we are only beginning to understand. But one question has always haunted us: how will it all end? The fate of the universe is one of the most profound and intriguing questions in all of science. Will it end with a bang or a whimper? Will it collapse in on itself? Or will it expand forever? For centuries, philosophers and scientists have pondered these questions, and today, we are closer than ever to having some answers. Join me as we explore the mind-bending possibilities of the universe's end. Imagine a universe where gravity wins. That's the basic idea behind the Big Crunch. In this scenario, the expansion of the universe, which began with the Big Bang, eventually slows down. Why? Because gravity from all the matter in the universe pulls everything back together. Picture a ball thrown up in the air. It goes up, slows down, and then falls back down. The Big Crunch is similar, but on a cosmic scale. As gravity pulls everything closer, galaxies would start racing toward each other, stars would collide, black holes would merge, creating even more massive monsters. Finally, all matter and energy in the universe would be compressed into a single, incredibly dense point. Much like the singularity from which it all began, it's a dramatic ending, a cosmic rewind of the Big Bang. Unlike the fiery finale of the Big Crunch, the Big Freeze offers a different ending, a cold and lonely one. Imagine a universe where the warmth of stars and the energy of galaxies slowly fade away. This is the fate that awaits us in the Big Freeze. In this scenario, the universe continues expanding forever. The galaxies, once close neighbors, drift apart, moving away from each other at an ever-increasing pace. But here's the catch: as it expands, it also cools. The energy that once fueled the stars and galaxies becomes more and more diluted. Think about how the air gets colder the higher you climb a mountain. The same principle applies to the universe. As it expands, the temperature drops. Similarly, as the universe expands, the energy within it gets spread out over an increasingly vast space. This means that the energy density decreases, making it harder for new stars to form. This means stars would eventually run out of fuel and die. The brilliant supernovae that once lit up the cosmos would become a rare event. New stars wouldn't form as easily. The regions of space that once birthed new stars would become barren and inactive. Galaxies would drift farther apart, becoming like islands in an ever-expanding cosmic ocean. The night sky would grow darker as the light from distant galaxies fades away. The universe would become a dark, cold, and desolate place. The once vibrant and dynamic cosmos would turn into a vast, empty void. Temperatures would plummet to near absolute zero, the point where all motion stops. At this temperature, even the atoms themselves would cease to move. Even black holes would eventually evaporate, leaving behind nothing but a faint whisper of radiation. The powerful gravitational forces that once dominated the universe would fade away. The Big Freeze is a slow, drawn-out end, a gradual descent into cosmic darkness. It's a universe that slowly fades away, leaving behind a cold, dark, and empty expanse. Now let's talk about the Big Rip, the most violent ending scenario of them all. Imagine the fabric of space-time itself being ripped apart. That's the terrifying prospect of the Big Rip. This theory proposes the existence of dark energy, a mysterious force that's pushing the universe apart at an accelerating rate. If dark energy continues to increase, it could eventually become so strong that it overwhelms all other forces, including gravity. The result? A cosmic catastrophe. First, galaxies would be torn apart, then stars, then planets. Eventually, atoms themselves would be ripped to shreds. Even space-time, the very fabric of the universe, would be torn apart. The Big Rip is the most extreme scenario, a cosmic doomsday where nothing, not even the universe itself, can survive. Section 5, the heat death, fading to black. The universe, as we know it, thrives on energy. From the smallest particles to the largest galaxies, energy is the driving force behind all cosmic events. Stars shine brightly, galaxies collide, and black holes consume everything in their path. All because of the energy that permeates the cosmos. But what happens when that energy is evenly distributed, leaving no room for further work or change? This is a question that has puzzled scientists and philosophers alike for centuries. That's the concept of heat death. It's a theoretical scenario in which the universe has reached a state of no thermodynamic free energy, and can no longer sustain processes that increase entropy. Imagine a cup of hot coffee placed in a cold room. Initially, the coffee is much hotter than the surrounding air. Over time, the coffee cools down as its heat spreads to the cooler air. This process continues until the coffee and the air are at the same temperature. Eventually, the coffee, the air, and the room reach the same temperature. This state is known as thermal equilibrium. No more heat flows because everything is in equilibrium. There is no longer a temperature difference to drive the flow of heat. The heat death of the universe operates on a similar principle. As the universe expands and cools, the energy that drives everything from star formation to life itself will be evenly distributed. As the universe continues to expand, the distances between galaxies will grow and the energy will become more and more spread out. Star formation will slow down and eventually cease altogether. With no more usable energy, the universe would reach a state of maximum entropy, where everything is in equilibrium. Stars would die, black holes would evaporate, and the processes that once fueled the cosmos would come to a halt. Even the smallest particles would eventually decay. Over incredibly long timescales, protons and neutrons would break down into even more fundamental particles, leaving behind a universe devoid of complex structures. The universe would become a vast, cold, and unchanging sea of nothingness, a place where no new stars are born, no galaxies collide, and no life can exist. It would be a state of ultimate stillness, forever frozen in time. This is the fate that awaits the universe if the concept of heat death comes to pass, a silent and eternal end to the cosmic dance that has played out for billions of years. Section 6. The current scientific view, a universe of possibilities. So, which of these scenarios is most likely? The universe, with its vast expanse and countless mysteries, presents us with several intriguing possibilities. Each scenario, from the Big Freeze to the Big Crunch, offers a unique perspective on the ultimate fate of everything we know. The answer, like much of the universe, remains shrouded in mystery. Despite our advancements in technology and understanding, the cosmos continues to elude definitive conclusions. The more we learn, the more questions arise, leading us to ponder the true nature of our existence. Currently, the Big Freeze, driven by the accelerating expansion of the universe, seems to be the most favored model among cosmologists. This scenario suggests that galaxies will drift apart, stars will burn out, and the universe will gradually fade into darkness. However, uncertainties about dark energy and the ultimate fate of the universe leave room for other possibilities. Dark energy, a mysterious force driving the acceleration, is still not fully understood, and its properties could change our predictions entirely. The Big Crunch, once a leading contender, has lost some ground due to observations suggesting that the expansion of the universe is not slowing down, but accelerating. In this scenario, the universe would eventually stop expanding and collapse back into a singularity, potentially leading to another Big Bang. The Big Rip, while theoretically possible, requires extreme and as yet unobserved properties of dark energy. If dark energy's influence grows stronger over time, it could eventually tear apart galaxies, stars, planets, and even atomic particles. The heat death, a consequence of thermodynamics, remains a likely outcome regardless of which scenario plays out. In this scenario, the universe would reach a state of maximum entropy, where no useful energy remains to sustain processes that increase complexity. The truth is, we simply don't have all the answers yet. Our current models and theories are based on the best available data, but the universe is vast and full of surprises. Each new discovery has the potential to reshape our understanding of the cosmos. Our understanding of the universe is constantly evolving as we make new discoveries. As we continue to explore and learn, we may uncover new phenomena that challenge our current theories and open up even more possibilities for the fate of the universe. Section 7. The limits of our understanding. Despite our incredible technological advancements, the universe still holds many secrets. Our models and theories are based on our current understanding, which is always subject to change. Think about how much our understanding of the cosmos has changed just in the last century. We've discovered new galaxies, black holes, and even planets orbiting other stars. We've learned about dark matter and dark energy, mysterious substances that make up most of the universe but which we still don't fully understand. It's humbling to realize how much we still don't know. The universe is full of surprises, and it's possible that the ultimate fate of the universe is something we haven't even imagined yet. Section 8. the universe within us. While contemplating the end of the universe might seem daunting, it's also a reminder of the preciousness of life and our place in the cosmos. We are made of star stuff, forged in the hearts of dying stars. The very atoms that make up our bodies were once part of something much greater than ourselves. When we look up at the night sky, we are looking back in time, witnessing the light from stars that died long ago. In a way, we are connected to the entire history of the universe. Section 9. Our place in the cosmos. The vastness of the universe can make us feel small and insignificant, but it can also inspire us to live our lives to the fullest, to make the most of our time on this planet. We are part of something truly awe-inspiring, a universe that is constantly evolving and changing, and even though the universe may eventually end, our curiosity, our sense of wonder, and our quest to understand our place in the cosmos will continue to burn bright. So the next time you look up at the night sky, remember that you are witnessing a story that is still being written, a story that we are all a part of.